So we are live and continue with our trees algorithm. So let's take a look at the next task. Okay, so our next task is called amount of time for binary tree to be infected. You are given a root of binary tree with unique values and an integer start at minute 0. An infection starts from the node with value start. Each minute, a node becomes infected if the node is currently uninfected. The node is adjacent to an infected node. Okay, so it's binary tree and we have only 2 children. Return the number of minutes needed for the entire tree to be infected. Okay. So let's try to understand the question. So to understand the question, first we have our binary tree, and we have some infected nodes, node that called start. And we expect that actually nodes can be a lot, and all these nodes can be fit in our memory. And we always have infected node, right? So let's take a look. So if our root is infected, then output, so root infected, then output would be 0. Then we need to find the depths of 2 nodes, depths of children nodes, left and right. Then we need to find our infected node, and we also need to find whether it's on left or on the right. And also we need to find how many I mean also like depths of infected node, and if it's left or right. Okay. So by left or right, we can just iterate and return boolean actually. To find the depths, what we can do, we can we can do like DFS and return the maximum. So let's first try to find our DFS. DFS, we have our tree node. We have tree node and like depths, let's call it depths, and level. If a root is equal to null, we return level. And here we return, we do like 2 calls of root left, level +1, and here level +1, root right. and here it will be int left, here int right, and we return mass maximum of left and right. Okay, so first we can do something like this. Then we can return a boolean. Boolean exist, and here we not return level but start. We can do something like this. We can find infected, and if root val is equal to start, and here also it would be level, then return level. If root equal to null, we return -1. And here we again do these two calls, like for root. For root left, we do start level +1, and here it will be left and right. Root right start level +1, and we return mass maximum of left and right. Okay. So what we want now? Now we want the following. We want to find a boolean, like whether it's on the left. So we first we do like if root is can it be null? Not val. Each node has unique node. Yeah, at least one. Okay. So if root val is equal to start, then we return 0. Otherwise, we check find infected. We check root left. With start and with 1. Okay. And here we check if our level is not equal to -1, then we do something. Otherwise, infected. Otherwise, we looking for infected on the right. Okay. Then we find the depth left, and here we call this function root left and 1, and depth on the right, and here is right. Okay. Okay, so I think we can do something like this. All right, so now we know our infected level and we know the depths, right? So now we can calculate results. So let's call result equal to 0. And if our infected on the right, then we should add to our result the depths of our left node. So if equal to depth left, and returns the number of minutes needed for the entire tree to be infected. Returns the number of minutes needed for the entire tree to be infected. So it would be depth plus left plus 2, 3, 4, 5, like 1, 2, 3, 4. Yeah, so it would be 4, and here we should return like mass minimum of depth left plus depth right minus 1. Otherwise, it should be something like this. And we return our results. Well, let's check. Okay, level infected, let's see. Okay, so we have wrong answer. Output is 2. Yeah, maybe maximum. Right. Upgrade premium use. Yeah, we have okay. What if we have this test case and 1, and let's run it. Okay, so we have run. We have 1. Yeah, so that's true. So when we have root equal to value, it should be not 0 actually. It should be return. We are looking for depths of both of left and right, and we mass maximum of this two. Depth level output here, output for expected -1. Yeah, because we don't need, yeah, -1 because we are not need to count this root. Okay, now we have another issue. Well, let's check it. Run. Okay, we have 4 equal to 2. 1, 2, 3. So it's actually should be 3. So how it works? We have our result. We find first on the left our infected. Okay, so we found our infected, and we have depth and depth right. Okay. Yeah, we see that it's infected on the left. So we go here, and we found 4 positions here. But we should be like not only -1, but also we should do like mass maximum, or even not maximum, but minimum between depth left -1 and it should be not depth length -1. It should be also minus infected, I believe. And here as well. Okay, we have another 5, starts 4. Okay, so we have 4, an output. So we should also count this one. It's this one. And also it should be I think depth. It should be probably maximum, mass maximum between this one and also depth left. So we should depth left minus infected on 1, 2, 3, 4. Yeah, just maybe infected. Check. And yeah, probably here as well. Mass maximum between depth right -1 and infected. Okay, one more. Yeah, for sure we didn't pass. Let's try to check what we have. Okay, now we have 4. But output is 2, but we expect infected plus Mouse depth plus depth left, I believe. And here, infected plus depth right. And here should be -1, -1. Okay. Okay. Another one. Start 4. We have 4. Okay. So we have this one and this one. Yeah, I think it's not working solution at all. Let's try to find out what we have hint here. Convert the tree to an undirected graph to make it easier to handle. Use BFS starting at the start node to find the distance between each node and start node. The answer is maximum distance. Okay, do we have some editorial? Convert to graph and breadth first search approach. Okay, so we have convert function. Okay. One pass DFS. Okay, yeah, I think it's interesting, but I didn't solve it today.